Hello, this is Keenan Park, and this is YLOC 4th grade worksheet lesson 14. We will be starting off with the first section where we solve with the remainder. So we're going to do the division, but instead of having a fraction or a decimal, we're just going to find the whole number, and then the remainder. So 5 divided by 2, 2 goes into 5 two times, but that leaves a remainder of 1. So the answer is 2, remainder 1. 38 divided by 3. The largest number divisible by 3 that's lower than 38 is 36. And 36 divided by 3 is 12. So it will be 12 and the remainder of 2 because there's the 2 remaining because 38 minus 36 leaves 2 remaining. And then 14 divided by 5. 5 can go into 14 two times. And then since 5 times 2 is 10, there'll be 4 remaining. 14 minus 10 is 4. And then if we move down, 70 divided by 14. This actually divides perfectly. It divides, 14 goes into 75 times, and then there'll be 0 remainder. And 2 divided by 5. 5 goes into 2 0 times, and then there'll be a remainder of 2. And 18 divided by 7. It goes in twice with a remainder of 4, because 7 times 2 is 14. 111. It goes in 11 times and has a remainder of 1, because 10 times 11 would be 110, and so there'll be the 1 remaining. And then lastly, 72 divided by 13. This goes in 5 times, and then 13 times 5 is 65. So we will have a remainder of 7, because 72 minus 65 is 7. Moving on, this is the modulo operator. It sounds fancy, but it's not really anything special. It's actually easier than what we were doing. It's just the same thing as the division, but you ignore all of the stuff before the R and the R. You only have the remainder. So 13 mod 3, the remainder is 1, and so 13 mod 3 is 1. So 14 mod 10, if we did 14 divided by 10, the remainder would be 4. So 14 mod 10 is 4. And mod is just short for modulo. 30 mod 25 will be 5, because 25 goes in one time. We ignore that, and then there'll just be 5 remaining. 73 mod 15 is 13, because the highest multiple of 15 will be 60, and then 73 minus 60 will be 13. And then 99 mod 42, the highest multiple of 42 will be 84, and so there'll be 15 remaining, because 99 minus 84 is 15. A similar process for 53, 48 is the highest multiple of 6, so we'll have a remainder of 5. For 33, we'll have a remainder of 9, because 24 is the highest multiple. For 119, we have a remainder of 7, because 112 is the highest multiple of 8. That will go in that before 119. And then for our last question, we have 225 mod 20, which will just be 5, since 20 can go into 220, and then 225 minus 220 will be 5. And then for our word problem sections. So we have azathoth, and azathoth is thinking of a number less than 100. When this number is divided by 7, its remainder is 0. When the number is divided by 2, its remainder is 1. When the number is divided by 5, its remainder is 1. And when the number is divided by 11, its remainder is 3. So what is his number? So we know from the first part, its remainder is 0 when it's divided by 7. So that means it's divisible by 7. It's one of the multiples of 7. So I will just write them all out right here. 7, 14, 21, 28, 35, 42, 49, 56, 65. I'll move on to the next row. No, it's not 65, sorry. Is there an eraser? Yes. It's 63, and then 70, 77, 84, 91, and lastly 98. It says when it's divided by 2, its remainder is 1. So what does that mean? Well, that means it's an odd number because even numbers are all divisible by 2, which means the remainder will be 0. And so odd numbers will have a remainder of 1. So that means I'll use blue. It's not 14. It's not 28. In fact, every other one is even, and we know it's not even. So we can just remove every other one. And the next one is divided by 5, its remainder is 1. So that means, well, if a number is divisible by 5, it ends with 5 or 0. And if its remainder is 1, that means it'll be 1 more than that. So end with 6 or 1. So that means not 7, but 21 ends in 1, not 35, not 49, not 63, not 77. So we can see 91 or 21 are our only two numbers left, which is good. And since we have this one last thing, we can find out. When a number is divided by 11, its remainder is 3. When 21 is divided by 11, its remainder is 10. And when 91 is divided by 11, its remainder is 3. So we know it's 91. So Azathoth's number is 91. Next, Cthulhu is making as many cakes as possible. Each cake requires the same number of eggs. If given 1 dozen eggs, Cthulhu will leave 5 eggs remaining. If given 2 dozen eggs, Cthulhu will leave 3 eggs remaining. So how many eggs will Cthulhu leave if given 3 dozen eggs? So 1 dozen is the same as 12, and 2 dozen is the same as 24, and he'll leave 5 eggs, and he'll leave 3 eggs here. So if he's leaving 5 eggs, that means he used 7 eggs. And in this case, he used 21 eggs because he leaves 3 remaining. So we know that each cake is just 7 eggs. And so he makes 1 cake when given 1 dozen eggs, and he makes 3 cakes when given 2 dozen eggs. And so if given 3 dozen eggs, he'll have 36. And then he'll use as many cakes, he'll make as many cakes as possible. And so since we're doing cakes use 7 eggs, we'll do mod 7. And so we'll just get 1 because 36, the highest multiple of 7 will be 35, making 5 cakes. And then he'll leave 1 egg remaining. So he'll leave 1 egg. And you can use the modulo operator to find out if a number is even, like I said previously. If the number, let's say this is some number named n, if we say the number mod 2 is equal to 1, then n is odd. If it equals 0, then n is even. Because if it equals 0, that means it's divisible by 2, and even numbers are divisible by 2. And if it ends with 1, that means it's not divisible by 2, which means that it's odd. And that's all for today's lesson.